A stacked variational autoencoder, or a Boltzmann machine, a perceptron with a set of inputs that go into a hidden layer, and then they're also fed as output into another inverse function or a modular function that projects a set of concatenated values based on a probability distribution. This is the essence of what we're talking about here. As you can see on your screen, if we have an ensemble, a dynamic directed acyclic flow, a perceptron, and we're able to pool a set of classifiers, we're able to also generate a extreme learning evolutionary system of learning by dealing specifically with that Riemann manifold. Riemann, the name of that infamous German mathematician. And when we deal with projections at the scale of finding exhaustive searches of a grid, we're able to cluster segments of the population that at one point share an origin or share a specific intersection. And this is the foundation of deep learning, which is finding secrets from data. In this case, we're whispering a message. We're transmitting a JSON event giving us a state of the network, the state, the snapshot that we need to run the virtual machine on our cluster, on our Mesos instance. This is all taken care of via Webhook and Grafana. When you're extracting information from a Prometheus database or an InfluxDB, our query will come with a timestamp, key value, and array tuple. It's essential for this course to understand that the hack in the stack is inside the alert management system, because the only way that we can build a recurrent neural network or a deep neural network of any kind is for us to have a metric and a benchmark for a model, a conglomerate of metrics with a fitness function, of course. And this will become clear when we're dealing with the back propagation, as we saw earlier as well. You got an idea of how those weights get activated, how those weights get their values, and they're all dynamically. You have to think of this as a bottom top sometimes, or something you can do vice versa, top bottom. But you have to think of a dynamic programming scheme here of containers. And as we saw before, these get fed information from the previous state. And so they are, in that sense, always changing. Now, Keras is an amazing library for artificial intelligence and machine learning, which allows us to encapsulate this idea of hidden layers in a graph sense, meaning you have an object or a struct, a meta object with a set of parameters, give it that stratification, that you can actually call in this event, call in this object, infer a state, do something with it, dispatch a set of commands, or cancel a set of jobs. And every single layer can be activated as you wish. If you want to do a hyperbolic tan, if you want to do a simple sinusoidal transformation, if you want to do a Fourier inverse transform, you can do these things simply by using Keras in your sequential model with RStudio. And you can go over the previous lectures as well to brush up on R and building a deep neural network in RStudio with DPLY. It's just an amazing variety of R libraries for you to really disentangle a CSV, a nonlinear time series, if you will. And going back to Keras, the ability for you to treat the flow of information as a graph or an edge-friendly protocol, you're able to distinguish between certain characteristics in the data that you want to silence and others that you want to amplify. Having that ability gives you power.